So hi everybody, this is about exercise 6.5 question number 23. I am going to explain that. Please try to concentrate. Look at your textbook. So prove that the volume of the largest cone that can be inscribed in a sphere of radius r, capital R, is 8 by 27 times the volume of the sphere. That means there will be many cones we can inscribe in a sphere. If you take a sphere, in the sphere I can inscribe however, like this I can inscribe, like this I can inscribe, many ways I can inscribe this cone. But we have to take the largest cone which is inscribed in a sphere is equal to 8 by 27 times the volume of the sphere. We have to prove that. So, but the radius of the sphere is given, that's all. That means radius of the sphere is capital R, it is given. That is only the constant. So, I am just taking this cone inside the sphere, so which is inscribed in the sphere. So, this is given that the radius of the sphere is capital R. See, this is capital R. Now, the radius of the cone is small r. Now, if you take the height of the cone as small h, if the height of the cone as small h, then you can take this part. If you take from O to P, this will be h minus r, because the height of the cone is h. Therefore, you can take this OP as h minus r, and if you consider this point as Q, OPQ is a right angle triangle. OPQ is a right angle triangle. Then you get h minus r whole square plus r square is equal to r square. The further we get use of this one, this statement, because it is a right angle triangle. Pythagoras theorem is applied. Alright. Now we have to prove. So remember, volume of the largest cone inscribed in the sphere is 8 by 27 times the volume of the sphere. So that means volume of the largest cone, they said. That means the largest cone inscribed. The cone is largest, means the volume of largest cone inscribed means volume of the cone must be maximized. That means volume of the cone should be expressed in one variable. After that, you should do first derivative test and second derivative test. What is the volume of the cone formula? So the volume of the cone is equal to 1 by 3 pi r square h. Try to remember, capital R is constant because sphere is fixed. Capital R is the radius of the sphere, that is constant. Small r and small h are the variables which are for the dimensions of the cone. Now 1 by 3 pi r square h. But here r and h, small r and small h, both are variables because those are dimensions of the cone. They will be always variables. So because cone is variable inside, right? So we have to express this volume in one variable first. After that you can go for first derivative test and second derivative test. So from this statement, Pythagoras statement, we can say that r square is equal to r square minus h minus r whole square. R square is equal to r square minus h minus r whole square. So if you simplify this, open a minus b whole square formula, you get r square minus h square minus r square plus 2hr. So it is capital R square and small r square will cancel, which is minus h square plus 2hr, minus h square plus 2hr. So then it is r square is equal to this much, you can substitute here. Then you get 1 by 3 into pi into minus h square plus 2hr into h. Now capital R is constant, small h is variable. So this expression is in terms of only one variable expressed. So the volume is equal to 1 by 3 pi into minus h cube plus 2h square r. Minus h cube plus 2h square r, that is volume. So expressed in one variable. Now first derivative test. For the first derivative test, you should differentiate this one. dv by dh. Why do we do dv by dh? H is the variable. We are differentiating with respect to the variable h. dv by dh is equal to 1 by 3 pi into minus h cube derivative minus 3h square plus 2h square derivative 4h into capital R is the constant. Right? Now the first derivative test was telling us to take dv by dh is equal to 0 in order to get the critical point. Right? So minus 3h square plus 4hr is equal to 0. So minus 3h square is equal to minus 4hr. So h is equal to 4r by 3. After simplification, we get h is equal to 4r by 3. That is the height of the cone expressed in the radius of the sphere. That's what we did it till now. But we have to say that this is a cone, volume of the cone is largest. That means second derivative test is needed. What is the second derivative test? D square V by dH square. Here is the first derivative. Here is the first derivative. So, sorry, here is the first derivative. So, differentiate this. Minus 3h square derivative, minus 6h, 1 by 3 pi into minus 6h plus 4h derivative is 4r because h derivative is 1. 4r. So, it is 1 by 3 pi into minus 6. What is the critical point? The value of h? 4r by 3. Substitute here. 4r by 3 plus 4r. So, 1 by 3 pi into, which is minus 8r plus 4r. It is 1 by 3 pi into minus 4r. So, it is negative. Minus 4r is negative. So, it is less than 0. So, therefore, you can say that volume is maximum. The cone is largest. When it is possible, when the critical point we got h is equal to 4r by 3. But we are asked to prove that. What we are asked to prove? We are asked to prove that volume of the largest cone inscribed in the sphere is equal to 8 by 27 times the volume of the sphere. So, volume of the sphere is 4 by 3 pi r. Volume of the cone is what we got here, 1 by 3 pi into something. So, just take it. Volume of the cone 1 by 3 pi into minus h cube plus 2h square r. Substitute. H is equal to 4r by 3 substitute. Minus 4r by 3 whole cube plus 2 into 4r by 3 into r. So, simplify. 1 by 3 pi into minus 64r cube by 27 plus here whole square because h square is there. 2 into 16 will come. 2 into 16, 32. R square into r cube by 9. Calculation after that, I get 1 by 3 pi into, it will be around 32 by 27 r cube. This can be written as 8 by 27 times 4 by 3 pi r cube. 8 by 27 times 4 by 3 pi r cube because 8 4s are 32 numerators. 32, 27 and 3. So that means it is 8 by 27 times volume of sphere. Hence proved. So there is one more way of asking this question. They will ask you to prove that the height of the cone, largest cone inscribed in the sphere is 4r by 3. There is alternatively they can ask the question as, same question they can ask as, height of the largest cone inscribed in the sphere is 4r by 3. What is the alternate question? Height of the largest cone inscribed in the sphere is 4 by 3 times the radius of the sphere. That's what we did. It is equal to 4r by 3. That means up to here only it is. According to that, this question, in textbook question, we have to prove that volume of the largest cone inscribed in the sphere is 8 by 27 times the volume of the sphere. Got it? Hope you got it. Understood? So, I will move on to the next question.